Good morning, children. In the previous class, we learned about the Newton's second law, and in the same way, we learned how to derive the Newton's second law, and we learned about what is momentum, linear momentum. Okay, what is momentum? Momentum is the product of the mass and velocity. Okay, with which letter momentum is denoted? With which letter momentum is denoted? With letter P. P is equals to mv, where m is the mass, v is the velocity. Any object which is moving, it has the momentum. Okay, and if it is moving in the straight line, we say it is as linear momentum. Basing on the momentum, we derive the equation for the force, that is F is equals to ma. Okay, where how we derive, that means basing on the principle that the force is directly proportional to the rate of change of momentum. Okay, children, right? Okay, as in the Newton's first law, I forgot to explain one small concept, that is inertia and mass. Inertia and mass. Inertia, already you are familiar with the word called as inertia. Inertia is the resistance of a body to change its state from one to the another. That means any body which is in the state of rest, or any body which is in the state of motion, it wants to be in the same state of rest or motion. It doesn't want to change. That resistance of not changing its state from one to another is called as the inertia. Okay, and here mass. What do you mean by mass? Okay, mass means, here mass is defined as the amount of matter contained in a body. The amount of matter contained in a body. That means whatever the matter that is present, chalk piece is there. What matter is present? The calcium carbonate, CaCO3. Calcium carbonate powder is mixed and it became hard. Okay, therefore CaCO3 is the chemical which is used in the making of this chalk piece. Therefore chalk piece consisting of the CaCO3, therefore that is the matter which is present inside. Therefore amount of matter contained in a body is called as the mass. And here each and every body in the universe has the mass. Okay, if the fan has the mass, a tube light has the mass, this camera will be having of the mass, the board is having of the mass, all the small pieces of the green board combined together, it forms of a huge body. Even though of ourselves, that means we too are made from the matter, but that matter is made up of what? Single cell. Okay, a single cell of the parent. Okay, it forms of a huge body. That means what zygote we say. Okay, that means a baby can be formed by using of a single cell. That is nothing but the single cell is called as the atom. Okay, all the atoms together, it forms the molecule. Okay, all the molecules combine together to form the matter. Therefore the amount of matter contained in a body is called as the mass. Okay, and here we are learning about inertia and the mass. Okay, inertia and mass. That means here inertia is directly proportional. Inertia is directly proportional to mass. What do you mean by this? It is directly proportional to the mass. Okay, inertia is directly proportional to the mass. That means here whenever when the mass is increasing, inertia is also increasing. Inertia is increasing by the mass. When mass increases, inertia also increases. When the mass decreases, inertia also decreases. Let us take an example. On the road, a cycle was there. In the same way, a car is there. We want that means here cycle, it is not inflated. That means it is the tires have been burst. Therefore we want to move the cycle to the cycle stand. Okay, in the same way car fuel is completed. Okay, therefore as the fuel is completed, what we should do? We are moving of that car near the petrol bunk. Therefore, when we are moving, which one is easy for us, whether to move the cycle or whether to move the car? Which one it will be easy? That means it is easy for us to move a bicycle than a car. Why? Why? Because bicycle is having of the lesser mass. Therefore, lesser is the mass, lesser will be the inertia. That means the resistance to change its state for the motion of the body. The resistance to change its state from the rest to the motion, okay, that is nothing but what? Inertia. Therefore, here when the mass is less, inertia will be less. Therefore, easily we can move the bicycle from one place to another place. But in order to move the car, we require more number of people. Why we require more number of people? Why? Because here more will be the inertia. More is the mass. Normally, car it will be of more mass. Therefore, more is the mass, more is the inertia. Okay, children. Therefore, here what we can say? We can say that inertia is directly proportional to the mass. Okay. Here in the textbook, he asked about pushing of two wooden boxes with same forces. Okay, pushing of two wooden boxes with same forces. Okay, that means here there are two boxes are there, wooden boxes. Okay, one with the heavier mass, one will with the lower mass. Okay, lower mass, heavier mass. We are giving off by using of a scale. By using of a scale, I am pushing of the two bodies. Two bodies same shape, same size, but here mass is different. More here, more mass here, less mass here. Therefore, when we are moving with the scale, applying of same force both on both of them. I am applying of same force on the two wooden blocks. Which one will be moving faster? Lower mass object, wooden block will be moving faster. Why? Why? Because it is having of lower mass. Therefore, lower will be the inertia. As lower is the inertia, it can be moved to far distance. But whereas heavier mass body, as it is offers the more resistance, means more inertia. Therefore, it cannot move. It cannot move easily from one place to the another place. Okay, children. Therefore, here we say that inertia and mass are interrelated. Inertia and mass are directly proportional to each other. Okay, that means more is the mass, more is the inertia. Therefore, if we want to move an object, if it is of a lesser mass, we can easily able to move the object easily. If it is of heavier mass, we should effort more force. Okay, we should effort more force in order to move the body from one place to the another place. Okay, children, that is about the what? Inertia and as well as the mass. And here an example is given. A body of mass m is kept on the horizontal floor and it is pushed in the horizontal direction with a force of 10 newtons continuously, so that it moves steadily. Draw a free body diagram. What is the value of friction, he is asking. Okay. Here what is the free body diagram of the body means? Here force of friction, we are force applied force is applied. Here friction force also will be the same. And here net force or normally the weight is applied on the body and normal force is applied in the opposite direction. Vertically position, here it is the horizontal positions. Therefore, here what happens? The net force, here net force is equals to 0. Net force is equal to 0 means here net force is nothing but the sum of the two forces acting on the body. Therefore, here F minus F is equal to 0. Therefore, here we get F is equal to capital F. Therefore, what is the frictional force? What is the value of the friction? The value of the friction is same as that of the value of the applied force. Okay, children. The value of the friction force is same as that of the value of the what? Applied force. Therefore, the value of the applied force is how much? 10 newtons here given. Value is 10 newtons. Therefore, what is the frictional force? It is also 10 newtons. Okay, it is also 10 newtons. Okay, children. This is about the inertia and the mass. Okay, children. The remaining we will be learning in the next class, children. Thank you.